What is up, guys? In this video series we're going to be going over how we can learn C++, and it's definitely a good language to learn if you're jumping into programming because it is a lot more complex than Python or Java. It's kind of like the base of these languages. So if you learn C++, you will essentially be good off in every other language. But to get started, you can see we have this very simple program that is going to take our name as an input and then it's going to print it out to the console. So if we go ahead and run the program, you're going to notice in the terminal, it's going to ask me to enter my name. And I'm just going to enter that. And then it's going to say, hello, my name. And if you run the program again, you can enter another name. You can even say James if you want. And it will say, hello, James. So that's going to be the first program that we're going to create in C++. And with that, I'm going to explain what all of this means. So one thing I want to specify is that we are going to be using Visual Studio Code for this. And to create a C++ file, you just have to click on C++ and then save this with the extension of .cpp. So we can say hello sample.cpp. And save it somewhere that you can find it, of course. Then the editor for C++ will initialize. And I'm also going to go ahead and specify that I have a few extensions installed. If you go to the extensions tab, you'll find one that says C++, such as this one provided by Microsoft. I have also a compiler for compile running and a code runner. And these are just ones I have included. I'm not going to explain how to set this up. You're going to have to do your own research for that, but these are the things I'm using on my MacBook. But going back to our main file, as you can see, so far we have nothing, and the first thing we want to do is include a library, an IO stream. And this just helps us with inputs and outputs into the program. Then we want to create an int main that every single C++ program needs, because this is where the program runs. It has a main function where you can actually put the code in and run it. So that's going to have an open pair of parentheses. And inside here, we're going to refer to a standard library, which is called std. And with that, we want to first refer to string, which is a form of text. And we want to give it a name, which I'm just going to call username. And that's going to equal an empty string initially. And in C++, we need to always provide a semicolon after each statement because that will tell us that the line ended so the program can compile faster. Next, we're going to go ahead and still write std to take C out from the standard library, and this is going to provide us the possibility to print to the console. So with two left arrows and then the quotation marks, we're just going to type in enter your name and space, and remember the semicolon. We're going to do the same thing, except this time we're going to type in C in, and this time, since we are inserting into the console, we can just type in the username that we have created and provide a semicolon. Finally, we're still going to refer to our standard library and type in C out, and here we're going to use something new, which is a escape. And as you can see, by doing /n, you're going to have a new line printed in the console. So this just makes it nicer to look at in case you want to have one line after the other. So we need that new line for this example. We're going to type in hello, and in C++, the two arrows kind of act like a plus. So we can just add that. We're going to say hello username plus an exclamation mark with two backslashes. And also we want to return 0, which means the program has terminated and can exit out of this. Otherwise, it will just continue running endlessly. But now let's go ahead and save the program by doing Control or Command plus S. And we can just run it by doing Command plus R if you have one of these packages installed. And as you can see, if you forget a semicolon, the program is nice enough to tell you you forgot it. We can go ahead and rerun the program, and it's going to tell us to enter our name once again. So here we're going to go ahead and say this time Luigi, and it's going to say hello Luigi. And to go back to what I was saying earlier, if we remove these escape slashes, and first I will clear the console, but if we rerun the program now and we enter the name of Mario, you're going to notice it's going to stay all on one line, and that just makes it a bit harder to read in some cases, but otherwise everything looks pretty good. So just as a personal preference, I would add maybe a backslash like that, so it can separate it from the next command. And this time we can put Toad. So hello Toad. And then you got some space and it will give you the next terminal line. What is talking about data types and so on. So let's get started immediately by first creating the include iOS stream, and this time we can just type using namespace std, and of course we need to go ahead and create our main function. So int main, and open up a pair of curly brackets. And at the bottom we want to return 0, and I'm just going to write that now since we always have to do that. Actually, the first thing I want to go over is how to comment. So in case you ever want to leave a small message for what something does, or a small reminder to yourself, you can just add 2 slashes. Now if you write on another line, you're going to notice it's not going to be commented out. And that's because they also provided a different kind of comment, which is a slash asterisk asterisk slash, and everything inside here will be written in multi-lines, which means, hello there, this is a multi-line comment. And as you can see, it's all going to remain green, which means the compiler will ignore that, and you can write on multiple lines in case you have a larger piece of text you want to comment. Comments can also be used to comment out code in case you want to ignore a small piece of code for a moment or for a longer period. And of course, you can use the multi-line comment to ignore blocks of code. So essentially, that's the very basics on what commenting is used for and how it works. Now let's continue with the data types. So inside here, we're just going to add a comment. These are the data types. And the first one I'm going to cover is the int, which is any whole number essentially. So you can type in 10, you can type in 1,000, you can type in 150, whatever number you want, essentially. Then we have something that comes from the standard library, which is a string. A string is any form of text, and we can just go ahead and type in hello, but it has to be in double quotation marks. So here we can type in how are you, and that will be considered a string. So, I mean, you can also add numbers in here, or true and false. It will be considered text as long as you identify it as a string. As you could see here, we could type in anything we want. I'm going to just change it to hello because that's what I named it as. Next, we should go after the char, which is a shortening for character. So you can give it a name of letter if you want, and this has to be in single quotation marks. This can be a 1, this can be an X, this can be an O, it can be any symbol you want essentially. For this example, I'm just going to go ahead and add a weird Scandinavian symbol, such as the Ö, and leave it at that. Next we have booleans, which have 2 states, true and false. So here we're going to create a boolean called isTrue, and we're going to set that to false. But of course, if you wanted to, you could also set this to true. And these are just used for simple checks. And you'll see how that works later, of course. But all you need to know is that booleans are true and false. Next, we have floats and doubles. So here I'm going to call float decimal 1, which is just going to equal 10.12345. And a float is good because it goes up to 7 decimal precisions, which means 7 decimal points is how precise it will be, essentially. And double is very similar to that. We're just going to call it decimal 2, and we can still type 10.12345. And what's nice about a double is that it goes up to 15 decimal precision points, which means with 15 decimals, you're going to have more accurate results, and that's going to just be more precise. So that's essentially the only difference between a float and a double, is that double is much more precise. So if you need your code to be precise, you use a double. If you only have 1 or 2 decimal points, it's not going to really matter because they're not that precise anyway. But in most cases, you would prefer to use a double for the precision. And finally, I also want to cover an identifier, because so far all of these variables that we've created can be changed at any point of the program. If we want to change number to something else, all we have to do is type in number equals 20. And now this number is going to be changed to 20. But let's pretend we don't want that, because we have something such as pi, which is always going to be 3.1415, and we don't want that to change. So what we're going to do is provide this constant identifier, which means it just tells the program that this variable right here should never be changed. And if we go and type in 3.1415, you're going to notice that now if we try to change pi to something else, such as pi equals 10, the program is not going to be happy because we decided to make it a constant. So that just prevents some errors in the future. It's very good to tell people, or if you're working on a team, that this should not be changed. This is a constant. And a naming convention for constants is to have everything in uppercase. So that's why pi is written like that. If you had something else like a key, it would be written like API underscore key, and that would be the naming convention. But we're going to leave it as that. Now I'm going to show you a quick trick on how you can assign multiple variables on one line. Pretend you have X, Y, and Z and you want to assign them all different numbers. It's kind of annoying to have to write this on multiple lines, so you can just go ahead and type in int x equals 1, y is going to equal 2, and z is going to equal 3. As you can see, we save some time by writing that all on one line. This is absolutely acceptable and it looks great. It's easy to read. But now let's go ahead and print some of this stuff. So we can go ahead and type in system out. The answer is, add this concatenation, x plus y plus z. We're going to add another 2 arrows. And in the last video, I showed you that with a backslash or /n, you can create a new line. Another way to do this is to use the standard library with endl. And you might have noticed this time that because we are using the namespace std, we did not have to write it in front of you or this one over here. It was just straightforward and made it look a lot cleaner for this part right here. One downside to doing this is that if you have really large code, it can create lots of issues because you might end up mixing libraries that shouldn't be mixed. So writing std in front of each one of them just makes it a lot more specific, which in a way can make your code a little bit more maintainable in the future. But for smaller programs, this is perfectly acceptable and it actually makes it easier to read. So I would recommend that. Let's also print the Boolean is true and create a new line, so end line. And we are also going to print hello because we would like our program to say hello to us. So as you can see, we actually got an error here that says that this character is too large for the enclosing character literal type, and that's because char is actually supposed to take the normal range of characters, which means an exclamation mark should be fine, a normal letter should be fine, but if you add some sort of weird special symbol such as this one over here, it's going to be much harder for the program to print that. And there are workarounds, there's special char types such as wchar-t and so on, but that's actually far beyond the scope of this video. One day we'll go over that so that we can actually print these characters. So for the purpose of this video, I'm going to change this to an exclamation mark. Then we can go ahead and output the letter, and I'm going to add an end line here. So if we save and rerun the program, you're going to notice we're going to get the answer is 6 for x plus y plus z. We're going to get 0 for is true, because I also forgot to mention that false translates to 0 and true translates to 1. So that's what Booleans essentially are. They're just a very simple way of saying 0 and 1. Then of course we have the string of hello, which says hello with an exclamation mark, as you remember up here. And finally we printed this character, which is a letter of exclamation mark, and that is printed down here. But we can also make that a large X if we want, and rerun the program, and you'll notice we'll get an X printed down there. Guys, in this video we're going to be going over operators which can help us with logical statements, comparison statements, and arithmetic statements. So let's get started immediately with the basic mathematical operators. And for this example, we're going to create a few integers. One's going to be an int, which is x, and that's going to equal 20. And we're also going to create a y, which will be equal to 8. So we're just going to print out all of the arithmetic operators we can use in programming. So let's get started by typing cout, and then we need to go ahead and create our first operation. And one of the most basic ones, of course, is the addition operator. So if we go ahead and run this program now, you're going to notice we'll get the answer of 28. Very similar to that, we have the minus, so we're going to get 12. If you want to do a multiplication, you're going to use an asterisk, which is going to multiply it. So if we save that and run that, we're going to get 160. And of course, to not leave out the division operator, we're just going to add that, which is just a slash, and we'll get 2 as an answer because 2 fits into 20 only 2 times. And if we wanted to get that to be a 2.5, we would have to go ahead and change this to a float and then do the operation. And then it would be precise enough to give us 2.5. But let's also talk about the modulus operator. So as you could see, when we use the division symbol, we only get 2, but we don't really know what the remainder is, which of course is 4, but that's what the modulus operator does for us. It calculates the remainder of the division, so 8 goes into 20 2 times with a remainder of 4, and that's how the modulus operator works. Otherwise, we have 2 more that we can use, and the first one is the increment operator. So Adding two pluses will increment the value by 1, which means we'll end up with a value of 21. Otherwise, if we do minus minus, you'll see that we will end up with a value of 19. And if you do plus plus, it's first going to print the result and then increment it. So we actually have to go ahead and print x one more time to see that it effectively incremented the result. So now if we run the program, you're going to notice we're going to get 20 for the first print statement and 21 for the second, because this tells the program that this is the value we want to be printed first and then incremented after. So that covers the basic arithmetic operators. Now you may have noticed that the plus plus is really nice to increment the number by 1. But what if we want to increment it by 4 or 5? So let's delete this. And before, we're just going to assign a new value to x. So we're going to do x equals x plus 5. Now if we save and print out the value, we'll get 25 as the answer. But what I want to show you here is that there is a shortcut for that. And if we go back, we just add a plus there, save, and we will get the exact same result with some cleaner code. Now this also works with multiplication, subtraction, and division. So you can just do that to save a small line of code. So now we have 20 times 5. And if we actually duplicate this line of code, we're going to get 500. And there's not really much more to explain about that. You can even use the modulus operator and so on. It's just a fast way to increment a value that we've already defined. But let's get rid of that and move on to comparison operators. So comparison operators are used for checking whether a statement is true or false. So they can only return either true or false, which is correspondent to 0 and 1. So let's go ahead and check whether x is greater than y. To do that, we would go ahead and type in x, and we would add the right arrow and type in the y. So just like in algebra, we can check whether one value is greater than another. And we have to put a pair of parentheses around this. Now if we save and print, it's going to return 1 because that is a true statement. We can also check if they are equal to each other, which is not going to be the case. So it's going to return 0. And we can check if it's not equal to y just by adding an exclamation mark. In general, it's going to do the opposite of whatever you're checking. So the exclamation mark is pretty much a not. So now if we go ahead and run the program, we're going to get true because x is not equal to y. Now there's something else you should know. If x is more or equal to y, let's just pretend that y is 20 for some reason, this operator is going to return true because x is more or equal to y. So if we run the program, we'll have a 1 as a response. Otherwise, if we just leave that, it's going to return false because y is not greater than x. And you can do it the other way around, of course. So this is going to return true, and the other way around is going to return false as well. So those were the basic comparison operators. Now let's go ahead and change y back to 8. And the final thing I'm going to show you are the logical operators. So logical operators can help us with multiple statements. So actually for this example, I'm going to go ahead and add z, which is going to equal 10. So here we're going to write x is less than y, and we're going to introduce the new logical operator, which is the and. So now we can check two statements in one line. And we're going to check whether x is less than z. So this is only going to return true if both of these comparisons return true. So if we save and run the program, we're going to get false because z is not bigger than x and y is not bigger than x. But if we turn this around, they're both going to be true, so we're going to get true as a result. But even if one of them is wrong, it's going to return false. But now we also have the double pipeline, which corresponds to or. So only one of these have to be correct for this whole statement to pass and return true. So as you can see, x is bigger than y, even though z is not bigger than x. And we're still going to get 1 as a return because that is true for one of these two. And the final one to include is the negate. So this will just do the opposite of whatever you're checking, which means if x is bigger than y, that's going to return true. And then we're going to change that x is bigger than z, which is also true. So this is going to check just the opposite of this, which means essentially we're going to have 0 as a return. And as you can see right there, we have a 0 because this is only going to check whether everything inside here is false. And if one of these things turns false, then we're going to get true as a response. So in general, you can just look at the exclamation mark as a negation symbol if you want the opposite of whatever you're doing. In this video, we're going to be going over our very first condition statements, and this is going to help us with making decisions in case something happens or in case something doesn't happen. And we can get started immediately by creating what we can call a mock chatbot. But let's go ahead and first create a string, which is going to take the name. And right now we're not going to enter any name, but we will update that very shortly. Then we will go ahead and type int number, because we will also be using a number for this. And we'll just set the value of 12. Now we're going to create an if statement. And again, this is going to check if a statement is true, this is going to happen, else something else will happen. So what we're going to do here is check if the name is equal to my own name. Then we'll go ahead and print to the console, welcome back, Federico, with an exclamation mark. So far, if we run the program, nothing's going to happen because the name has not satisfied this condition, which means nothing will be printed. But if we go ahead and type in my name here and rerun the program, it's going to say, welcome back, my name, because it has satisfied this condition. Now let's go ahead and give it some more options. So else if the name is something else, and inside here we should go ahead and insert name is equal to Philip, for example. We'll just go ahead and print out go away Philip and close that. And you can add as many else if statements as you want, but later on I'll show you that there's a more convenient way to use that than just writing a bunch of else ifs, but for this example, this is perfectly acceptable. And we're going to create an else statement that covers everything else that can happen. So in case they enter a name that's not part of these two conditions, we're going to print out hello plus the name that the person has entered, plus an exclamation mark. So now if we go and run the program, as you can see, it's still my name, which means we will get this as an output. But if we go ahead and change the name to Philip and run the program, the program's going to say, go away, Philip, because this is my program. And if we type in anything else, a name that's not recognized by the program, and rerun the program, it's going to say hello plus the name that the user has entered. So that's a very basic way on how you can use if and else. And it also works for numbers. What's important is that you just make sure it gives either true or false as a return. So let's go ahead and create something for the number. So if the number is more than 10, then we are going to print the number and the string is more than 10, exclamation mark. And it is not required to provide an else statement. Usually you just do that in case you want to handle something that's not covered by the if, but sometimes you can just insert an if you just want something to happen every now and then or on special occasions. So if we rerun the program, it's going to say that 12 is more than 10. And the same thing goes for 100 if we change the number to 100. But if we change the number to 9, we're not going to have anything printed because 9 is not more than 10. Now there's actually one last thing I'm going to show you for this example, and this is called the ternary operator. We're going to change this variable to time and change it to the hour 20. Now we're going to find out how we can make a statement much more simple, because it is annoying to go ahead and write if else for such a simple statement. And what I mean is we're going to create a string called greeting, and that's going to equal if the time is less than 12. We're going to use this ternary operator, which means it's going to return good morning. And just by adding a colon, we can add the false condition. If it's not less than 12, it's going to return good evening. Now if we go ahead and print out the greeting, we're going to have printed out to us good evening, because it has returned false for this statement here, which gives us this instead. And if we change it to 10 and rerun the program, it's going to say good morning. So as you can see, this is the exact equivalent to this right here. It just looks a lot more clean and it's a lot easier to write. So I definitely recommend, if you have a very simple if-else statement, to use the ternary operator. It works exactly the same way. You can even write, if name is equal to Florian, then it's going to print good morning. Otherwise, if it's not equal to Florian, it's going to say good evening. So if we run the program, as always, we're going to have this very simple process that's going to give us the result of good morning. And that's essentially how the ternary operator works. It saves us the hassle of having to write if and else in a huge block of code. today's video, we're going to be covering both the switch break statement and the while do statement. So we're going to actually cover two different kinds of keywords that will help us with input and loops. So to get started, we're going to create an int, which is going to be called number, and that's going to equal 1. So the first thing I want to cover is the while loop. So a while loop will essentially go in an infinite loop until a condition turns false. So for example, if we go ahead and type in while number is not equal to 0, we want the code inside here to be executed. So to do that, we're just going to first tell the user to enter a number, and then we need to take some input. So we will type in cin and type in number. Then we will go ahead and type in cout and type in you picked, insert the number, followed by an end line. So what this is going to do is allow us to continuously enter numbers until we enter the number 0, and then the program will exit. So let's go ahead and run this. So as you will see, it's going to allow us to enter a number. So let's go ahead and put 10. It will say we picked 10, we picked 5, we picked 20, but as soon as we enter the number 0, this condition is going to change to false, which means we can exit out of this loop. So that's the basic concept behind how a while loop works. Now let's go ahead and also insert the switch statement into this while loop so we can create an endless program that continuously takes input until the user decides to exit. So inside this loop, we're going to create a switch statement. So just type in switch, and as you can see, it needs a condition, and I'm going to enter our number. So essentially it's going to check which number gets inserted in here, and based on the number that's inserted, we're going to be able to create a response. So for example, if the user inserts the number 1, we can go ahead and output that is number 1. And it's very important we provide the break, because the break tells the program that if it finds something that matches this number, it can exit out of this switch. Because you're going to notice that if we have more cases, we don't want the program to continuously search for them because it will waste memory, and we just want it to be efficient by finding the case that fits and not searching any further. So the break just tells the program not to search any further. So for the second one, we're going to copy this part right here and paste it inside here. And we can change the statement to 2 is cool. Then we can go ahead and actually duplicate this one more time. And we're going to change the case to 3 and say 3 is a B. And you can change these cases to any numbers you want. It can be 1,000, it can be 5. And finally, what happens if the user decides to insert something that is none of these cases? We can also decide to insert a default value so that no matter what they insert, this will always be printed in case there's nothing that's matching. So here we can create the cout, and we can type in you picked a very lame number. And inside the while loop, we're also going to create another print statement, which is just going to make some more space for us between each loop. So now if we run the program, it's going to tell us enter a number. We can start with 10. You picked a very lame number. We can say 3. It will say 3 is a B. 2 is cool. That is number 1. And as soon as we type in 0, it's going to say you picked a very lame number, and it's going to exit out of the loop because we specified that as soon as this becomes 0, the code should not be executed anymore. So in a way, you could even see this as our first program in C++, a program that can read our numbers and convert it to some text. Now, there's actually another thing I want to cover that has more to do with the while loop, because right here you can see that when we created the number, we had to initialize it with the number of 1 so that this while loop could get executed. Because if we enter the number 0 here, the while loop will say, hey, this is 0, and it will skip this entire block, which will waste our time essentially, because we wrote all of this nice code and we want it to be executed at least once. But there is a way around that. And this is the do while loop. So essentially you just write do, and inside here you write the code that you want to be executed. And this code should be executed at least once. So for example, let's go ahead and type in cout, and this time we're just going to write 2 and enter a number. So it's going to be very similar to the previous program, except this time we can even start the program if the value is 0. So we're going to take an input of number, and this simple program is just going to output that you picked number end line. And all of this is going to happen while the number is not equal to 0. And you can even change this to 1 or 2 or 3 or any number you want. This condition has to be true for this loop to work. So this time we can go ahead and change this to 0, and what that's going to do is skip the first loop, but it's not going to skip our second loop because we've provided the do, which makes it do this code at least once before evaluating this part right here. So we can rerun the program now, and you're going to notice it's going to skip to our second enter a number, and this time if we write 10, it's going to continuously loop because now we changed the number to something that is not 0. And if we do 2, it's going to say you pick 2. And as soon as we click 0, it's going to say you pick 0, and it's going to exit out of our program. So this was a very simple, realistic example of where you would use a while loop. You can also use it to print out many statements. For example, if we go to while number is less than 5, we can tell the program see out number I end line, or number end line. And what's very important is that you increment the number at the end of this loop. Otherwise this loop will go in an infinite loop because this value is set to 0. So here we just have to increment the number by 1 each time this loop executes. So if we go ahead and run this program, it's going to execute it 5 times. So 0, 1, 2, 3, 4. And then it will end because as soon as this becomes larger than 5, the program will say it's time to break out of it and end the program. And in this video, we're going to be going over the for loop. Plus, we're also going to be going over the continue keyword and how we can use the break keyword in loops. So to get started, we're going to create our very first loop. So we're going to type in for, and to create a for loop, first you need to specify an iterable integer from where you want it to start from. So that's going to start at 0. And then you need to provide a condition. So while I is less than 10, we want to increment I by 1. And it's my mistake. These are supposed to be semicolons. So just make sure you do that. And then we can go ahead and create our block. So inside here, we can insert what code we want to be executed for this loop. It's going to be executed 10 times because that's the condition we have specified, but we can go ahead and print loop. We're going to add number 1 because we will create multiple. And then we are going to go ahead and add the number or the iteration. Plus, it's a good idea to add an end line so that we can see the result in a clean fashion. So when we run the program, we will have 10 numbers that get printed, starting from 0 and ending at 9. So as you can see, this is loop number 1, and that's what got printed to the console. Now we also have the opportunity to increment the number by 2 or by 3 and so on. So if we do this, it's going to go up every 2 numbers. And if we rerun the program, you're going to notice we will only have 5 print statements, and that's a 0, 2, 4, 6, and 8 because we decided to step it up by 2. So that's the basic concept of the for loop, but we're going to change this back to the normal increment by 1. Now we're going to talk about the second thing that you can do inside for loops, and that's going to be on how we can break out of this loop early. So in this case, we can add an if statement. So if I is equal to 3, we're going to create a block and we're going to print out that loop ended early. And we're going to add an end line. So this will be printed when the iteration arrives to 3, and we will also break out of this loop. So now if we run the program, you should see only 3 numbers being printed because we gave it a condition to break from. So here you get 0, 1, 2, 3. It knows it's 3. It prints the statement or executes whatever code you have inside there and breaks out of the loop to end it early. And finally, let's go over the continue keyword. So we can actually just get rid of this, and we're going to change this to number 3. This time we're going to go above this statement. So we're going to write if I is equal to 3, then we're going to go ahead and write continue. So what the continue keyword does is break out of the current iteration and set it to the next one, which means once we arrive to 3, it's not going to execute any more of the code under the continue keyword, but it's going to start the next loop on loop number 4. So for example, if we go ahead and run this program, we're going to get everything printed out but the number 3, because once it arrived to number 3, it says, we need to continue the loop and it's going to stop it there and start it again at number 4. So that's essentially how the continue keyword works. And you can also use this stuff in while loops. The only difference between for loops and while loops is that with for loops you have a specific number of iterations, while in while loops you can go for as long as you want. In this video, we're going to be talking about arrays in C++ and how we can use those. So let's get started by creating an array. And the first thing we have to do is define what kind of array we want it to be. So it can be an int array, it can be a float array, it can be a string array. And for this example, we're just going to create an array of strings. So we're going to call this one names. And now all we have to do is create a pair of curly brackets and insert the strings inside here. So for this example, we'll go ahead and type in Mario, then we'll type in Luigi, then we will type in Toad. So far we have 3 elements in this array. Now, if we want to use this, all we have to do is create a cout, then we need to type in names, and we need to pick the index of the element that we want to print out. So just as a reminder, arrays start at the index of 0. So this is 0, this is 1, and this is 2. So if we want to print out Toad, we have to put a 2 inside here and then type in end line. Now if we go ahead and run this program, you're going to see in the console that we're going to have Toad printed out to the console. But there's also a way to print out all of these values. And to do that, we would have to create a for loop. So for int I, which is equal to 0, while I is less than the total amount of the items in the array. So we're going to type in 3. We're going to increment I. Then inside here, we can do the simple cout. We're going to add the I, followed by a colon, followed by the names at the index of I. And of course, each time we print one, we want to create a new line. Now, if we go and run this, we're going to have all of the names printed out to the console. As you can see right here, Mario is at the index of 0, Luigi at 1, and Toad at 2. Now, if you want to change one of these elements, all you have to do is type the element number, such as let's change Toad to Bowser. We're going to type in 2, and we're going to say that's going to equal Bowser. Now, when we rerun the program, you're going to notice that Toad is going to change to Bowser when we run it. And one more thing, right now we created an array without a set number of items. If you want to actually specify how many items are in the array, all you have to do is insert a number here, and this will reserve some extra space in case you want to add elements later. And the benefit of doing this is that you do not need to recreate the list if you want to add more items. For example, if we wanted to create something at the index of 3, this would not work if we did not add this number. But if we do this, we're going to have a new element added to the list, and we also have to change this to 5, of course. You're going to notice we're going to have an empty space that's reserved because we've defined 5 elements, and we're going to have Bowser added at number 3. But if we take that away and change and just continue running the program's going to give us an error because it just cannot find the 3rd element. To make this actually work, we would have to recreate the list and add Bowser here instead. So reserving some space can save you some trouble in case you want to add items. And as I said earlier, of course, you can create other lists such as int numbers. Now we can type in 4, and that's going to equal a list of 1, 2, 3, and 4. Now if we go here and print that and change this to 4, we're going to get 4 numbers printed out. And just as the string array, we can change each one of these individually. So we can go ahead and type in numbers at the index of 2 should actually be equal to 10. And when we rerun the program, you're going to see that this will change to 10 and that we can use each one of these variables individually. What is up, guys? In this video, we're going to be talking about references and pointers in C++, and we're going to be covering the very basics of what these are. So the first thing I want to demonstrate is a reference, and a reference is exactly what it sounds like. It's kind of like an alias for a different variable, so it's just a different name that you can use for something you created earlier. And it's hard to explain, so I'm just going to create an example such as, let's pretend we have a fruit, which is a banana, right? Now we can go ahead and create an alias, or also known as a reference, to an item. And then that's going to equal the fruit. Now, because we entered this ampersand in front of the variable name, we can now use this as a variable name for fruit, and they both mean exactly the same thing. So if we go ahead and print this out, we can type in reference, and we are going to print out the item, plus we're going to end the line to make things easy. Now, if we go ahead and run this program, you're going to notice that printing out item is going to be the same thing as printing out banana. That is because we created a reference, which is just an alias for the previous item that we created, which was a fruit. And in short, that's essentially what a reference is. And we can also go ahead and print the memory address. Here we're going to go ahead and cout memory address. And we can also use the ampersand symbol to get the memory address, which means if we do and item, this is going to print out the memory address, and we're going to duplicate this line of code like that, except this time we're going to change this to fruit. So if we're not creating a variable, this is going to be used to locate the memory address on the computer. And to demonstrate, we will run this program, and you're going to notice that our temporary memory address for this variable is this code right here. And as you may have noticed, they both have exactly the same code, which means they are exactly the same variable. And again, we just created a reference for the fruit from earlier, and that's why we can print out banana by typing item. Now, since these are exactly the same variable, if we were to go ahead and change item to apple and then print out the reference, you're going to notice that changing the reference will indeed change also the original variable. So now we have the reference that's been updated to apple, even if fruit was initially set to banana. Now let's go ahead and talk about pointers. So how do we create a pointer? Well, first we want to define what kind of variable it is, so we're going to call it a string, and then we provide an asterisk immediately after. And we also need to provide a variable name, which for this example I can just call pointer, and then we need to provide the memory address of the variable. So this is going to be @fruit, and that's how we successfully created that pointer. So the basic difference between a pointer and a reference is that a pointer stores the memory value, while a reference just holds a reference to another variable. So if we go ahead and actually print this out, you're going to notice that the pointer is going to be very similar to the memory address, because they are essentially the same thing. Then let's print that. And as you can see, the pointer holds this memory address, which is also the same as the previous two. Now we can also go ahead and modify this pointer. So if we go ahead and use the asterisk pointer, and we change this to something else, and then we decide to print this pointer, I'm also going to show you that we can dereference it. So dereference, and what that means essentially. So to dereference it, all you have to do is provide the asterisk, just like we did over here when we renamed this pointer. And what dereferencing does is take the memory address and change it back into its original variable. So right now, if we go ahead and print this to the console, you're going to notice that when we dereference this pointer, it's going to have this text over here. If we just print the pointer, we're going to have the memory address instead. And if we don't change the pointer at all, it's going to have the item, which is apple. So let's just go back to what we had earlier. So now it's something else. And you might also notice that this is going to change each time you rerun the program, because each time you create a memory address, your computer is aligning some memory to this specific variable while the program is running. So that's why on your computer, this might seem a bit different. And yeah, those were the basics that I wanted to cover on how you can use references and pointers. In a future tutorial, we'll go more in depth about that, because of course this can be used with memory manipulation, but for an intro to pointers and referencing, I think this will suffice. In this video, we're going to be going over how we can create functions in C++ and what they do and how they can simplify our life. And to get started, we will go ahead and create our first function. So to do this, we have to start by typing in void, which means it doesn't return anything. Later on, I'll show you what happens if we type int or string instead, such as we have over here for the main function. In this case, we're just going to go ahead and write void, and then we need to give it a function name. So for this example, I will type do something, and you can change that with something such as turn on engine or connect to internet or anything that is descriptive towards what your function does. And functions are used to minimize rewriting code, because the point of programming, or at least object-oriented programming, is to write as little code as possible and maximize the reusability. So if we had to print something, we wouldn't want to write the entire print statement over and over each time we did it. We would want to simplify this process by creating a function that does the same thing each time we need to use it. So for example, inside here, we're going to go ahead and type in cout, and we're going to write I did something with an exclamation mark. And then we're going to add an end line. Now we don't have to copy and paste this each time we want to print this statement. All we have to do is go ahead and refer to this function and just duplicate that if we want to do it multiple times. Now if we go ahead and run the program, you're going to notice we'll have this printed 3 times, and we only had to write this statement once, so that we could reutilize it more than once. Now I'm also going to introduce to you guys the concept of a global variable. So for this example, we're going to create an int called c, and it's going to be initialized with the value of 0. This time you're going to note that it was declared outside of the main function, which essentially just means we can use it anywhere we want, because we want to use it in the function so that every time we increment it, it will update this value. If we declare it inside here, things can be a bit more difficult because we want to use it in the function we have declared above. So inside here, we're going to type in C++, and we're also going to add 2 left arrows here and add the C here. Now every time we call this function, C is going to increment by 1 and is going to update accordingly in our main function. So if we rerun the program, you're going to notice now it will say I did something 1, I did something 2, I did something 3. Because each time we call the function, it updates our global variable, which is out here, and prints it out accordingly. Now, one thing you need to keep in mind that's very important is that when you declare a function, it has to be in order, because C++ reads the program in order from top to bottom, which means if you were to place this down here instead, the program wouldn't be able to recognize it because you decided to use something that didn't exist yet, and then you gave the definition down below. So that's why you'd have to declare it above. But there is a workaround for this, because sometimes it's cleaner to have the code written down below. And to create a workaround, you would just have to type in void and of course the function name. So we'll type in do something, and this time it will be do something 2, and then add the semicolon here. So as you can see, we didn't provide any body yet, but now we can go and successfully use do something 2 before we've provided the definition for the function. But this also means that we have to go ahead and create that function before we use it, otherwise we'll just call nothing. So below main, I'm just going to copy do something and add a 2 here. So now we've declared the function do something 2 below main, and we can actually take away the previous one and take this one away as well and duplicate this twice. So as you can see, in a way this looks a bit more clean because we have the declaration right here and we have the logic below the main function, which will make keeping our global variables a bit more clean. And if we rerun the program, we will have the exact same result. And of course, you can add as much code as you want in here. The goal is to make this as reusable as possible, so you don't have to create an engine or a wheel multiple times for a single car. You can just create one engine and use that engine multiple times, so to speak. But that should cover the very basics of functions. In this video, we're going to be covering how we can add some parameters to functions and also what function overloading is. So let's get started immediately with an example. The first thing we want to do is create a function which is going to do something as always, but sometimes we want our function to do a bit more than just execute a single line of code. Sometimes we want to be able to insert values so it can adjust the function. And to do that, we can go ahead and specify some parameters. So for example, we can go ahead and type in string name and int age. And immediately inside here, we're going to use that information by typing cout name, and we're going to write is, and we have to provide age plus years old. And we will also add the end line. Now your editor might highlight the name, so it's probably going to tell you that you can change that and that you can change it to a constant reference. But for this example, I just want to show you that you can add parameters and that this is just to clean things up a bit, but we're going to leave it at string name for now. Now, if we go ahead and call this function do something, you're going to notice that we have to insert 2 different variables. So we have to provide arguments, in other words. And for this one, we can go ahead and type in Luigi, and Luigi will be 27 years old. And as soon as you provide those, you're going to notice it's going to say name and age. So when we run the program, it's going to execute what we entered, and it's going to print out the statement we've provided. And if we duplicate that, we can do Mario, and that can be 25. And if we print it, you're going to notice we saved a lot of time with not having to write this every single time we wanted to update it. There's also a way to add a default parameter in case you do not want to give the age, for example. All you have to do is provide what you want it to be if they do not enter anything. And we're going to set that value to 0. So now if we go ahead and create another do something function, and this time we type Wario, but we don't know his age, that's okay. The program is not going to give us an error that we did not provide it because we have a default parameter. And I forgot that. And it's going to say Wario is 0 years old because we did not provide an age, and this is the default. Another thing to keep in mind is that this must be in order. You must put the name and then the age for this function to work. You can't go ahead and write 27 and then Luigi, because the program will not understand why there is an int in the string and a string in the int. So it has to be in order for it to function correctly. Alright, so that was a very basic example on how you can use parameters in your functions, and that just simplifies having to insert values later. Next, I want to show you that we can actually return some values out of this, and also how to overload them and what that means. So for this example, we're going to go ahead and create a function this time with the int. So we're going to say calculate, and it's going to calculate int a and int b. And all it's going to do is return the value of a plus b. So it's a very simple addition problem that when we call this function, it's going to give us the a plus b. So one way we can use this is by creating a value, which is called int, and that's going to equal calculate 10 plus 20. Now, if we go ahead and print this value, you're going to notice that we're going to get the value of 30 because we decided to specify that this is going to return an integer, which means we must provide a return statement at the bottom of the code. And you can put whatever code you want inside here, as long as you return something at the bottom that is an integer. So for example, you can say, I am adding the numbers, add an end line. If you rerun the program, it's going to call this function, store it in a value, and then print the value that we have returned from this calculate function. Now let's go over what happens if you want to add some floats together, such as 10.5 plus 20.5. The program is going to say, what are you doing? It's an implicit conversion, and the program's not going to be able to do that because we've specified this to be an integer, and it's still going to give us the value of 30 because it will round them down, of course. What we are going to do now is something called function overloading. And to do this, all we have to do is copy the original function with the exact same name, except we need to change the parameters and the type. So we're going to change all of these to floats. So now you're going to notice immediately that this one's going to turn all gray and it's going to pick this one. And we also have to change this here to a float. That is because with function overloading, it is smart enough to decide which function to use based on what you input. If we change this back to 10 and 20, we also have to change this to int. You're going to notice again that it's going to change back to the previous function. So let's go back to float, and this time let's print the result. Now when we print it, we're going to get the value of 31 because it decided to add the floats together in this function. So that was the very basic introduction to how you can use functions and how you can insert parameters, and also how you can overload functions to make different calculations and save time with adding ints and floats. But with that being said, the sky is the limit when you work with functions. The only general rule you should follow is that you want to simplify your code and make it as reusable as possible. So functions can help you achieve that. In the next few videos, we're going to be going over the object-oriented programming side of C++. So let's get started immediately with creating our first class. And in general, a class is considered to be a blueprint for whatever you're making. So if you're making a car, you have the blueprint for the car. It has tires, it has a window, it has mirrors, it has an engine, and so on. So the class is just what the car is made of and what it can do. So for this example, we're going to create something called a YouTuber. So as you can see, to create a class, all you have to do is type in class, followed by the class name. The naming convention is to have an uppercase letter at the beginning, and then all we have to do is create a block. Inside here, we're going to provide a public access modifier, which allows it to be accessed from essentially anywhere, and we'll be going over what this is later. And the first thing we're going to do is provide a few attributes. What is a YouTuber? What does a YouTuber have? So the first thing we're going to type is string username, because every YouTuber has a username. And we're also going to provide a subscriber count, so subscribers. So far so good. We have a class named YouTuber, and we define that each YouTuber has a username and subscribers. Now let's go ahead and create an object of this YouTuber. So to create an object, you just need to refer to the class and give it any name you like. For my example, I will type in Code Palace, and now let's go ahead and edit the attributes so we can use them later. Now if we go ahead and type in Code Palace, you'll notice that we can access these attributes just by using the dot notation. So we're going to set the subscribers to 100, and let's also go ahead and set the username to Code Palace. Now we can go ahead and output it. So Code Palace dot username has Code Palace dot subscribers, and we are going to add the end line. Now if we go ahead and run this, you're going to notice it's going to say Code Palace has 100 subscribers, because we were able to access this object and use the values that we've inserted there. And the great thing about this is that we can just go ahead and copy this, place it right under object number 2, and this time we're going to change it to coding in flow. It's going to have 1000 subscribers, and we're going to change the username to coding in flow. We also need to make sure to change this to coding in flow. Then we will duplicate the print statement and change this also to coding in flow. So as you noticed, it was very easy to create a second object, and as these classes become more complex, you'll notice that this will save us a lot of time with execution and with writing code. So let's go ahead and run this part. Now you'll notice that coding in flow has 1000 subscribers and Code Palace has 100 subscribers. And it was that easy to create a class that controlled what it has and what it does. So we don't have to think about rewriting this each time and trying to remember what a YouTuber is made out of. So the whole point of the class is just to create an outline of what you're making so that you can simplify recreating that later. But I believe that's actually all I wanted to cover in the first video regarding classes and object-oriented programming. In the last video, we talked about how we can create classes and how we can give these classes some attributes so we can better define what they are. And in this tutorial, we're going to be going over how we can add some methods so we can actually add some functionality to our classes. So for example, the first thing we're going to do is go inside our class and provide a method. And to do that, you just have to create a regular function just as you always have, and just name it whatever you want it to do. For this example, I will say make video because YouTubers make videos, and we're going to provide a parameter which is the date. Then inside here, we're going to type in cout username is making a video. We will provide the date plus an exclamation mark, and then all we have to do is add the end line. Now, as you can see down here, we have what we created earlier, and the same way we did that, we can also call these functions from the class. So if we go ahead and type in Code Palace, and this time we can call make video, and the date will be set to tomorrow. So just by using the dot notation, it's going to refer to the object we just created, which is Code Palace, and it's going to use the data inside there to make this function work. And it also works for coding in flow, of course. So this class just has a set amount of functions and attributes that apply to every single YouTuber. So let's say coding in flow will make a video today. Now when we go ahead and run this program, you're going to notice we're going to have one that says Code Palace is making a video tomorrow and coding in flow is making a video today. So they both used the same method from the same class because we are both YouTubers, and having a class just simplifies that process that every YouTuber needs to make videos, and that's why we have a function that applies to all of them. Very similarly, if you had a car, you might have something that says turn on engine or lock door, because every car would most likely have this functionality, and you wouldn't want to recreate this every single time you make a new car. Every car follows a set pattern of functions and attributes, so a class can just save you time in having to redo that over and over if you want to change some very minor details. Now, what I showed you just now is a way to add a function inside the class, but we can also define it outside of the class, and to do this we have to do what we did earlier when we created a global variable, and that is just specify what you want the function to be named, such as update video. And then outside of the class, we can go ahead and type in void YouTuber, because we want to extend this class and we want to refer to the update video function. Then inside here, we can just go ahead and copy this line here to save time and say cout username is updating a video and remove the date. And what's cool about this, because we are extending the YouTuber class, is that we can refer to subscribers or the username from within this function, because everything that's inside our YouTube class will be made available in this extension over here. But just as we did earlier, we can go here and type in codepalace.updateVideo now, and the same thing with coding in flow. So coding in flow.updateVideo and rerun the program. Now you'll notice that CodePalace made a video and now he is updating the video, and the same thing with coding in flow. So it was that simple to add methods to your classes. So essentially that's how methods work when it comes to classes. As you could see, they were fairly straightforward. In this video, we're going to be discussing how we can use constructors in C++, and in the previous videos you might have noticed that we had to first create an object of YouTuber, which I named CodePalace and coding in flow, and then we had to manually update these ones to make sure that we can print out these values. Now in this video I'm going to show you a faster way to do that will simplify our object creation. So the way we're going to do this is by creating a constructor, and let's get started immediately by creating our first constructor. And as you can see right here, the way we create a constructor is by creating the class name inside, just like we would as a function, and inserting a few parameters such as string name and int subs. Now you might be wondering, what's the difference between having this one here and the class YouTuber? Just by defining a class name inside your class, it's going to tell the program that it has to trigger all of the code that's inside here each time we create a new object. And of course, the best way to explain this is to show you an example. So first we're going to go ahead and assign the name of name to our username. And we also want to assign the value from subs to our subscribers. And now every time we create an object, we also want to print out some data on how many subs the user has. So username has subscribers, and here we're going to type in subscribers, and of course add an end line. Now let's go to our main function and create a new object. So we're going to type in YouTuber, and we are going to recreate CodePalace as we did earlier, but this time you're going to notice that we can't just create it the way we did earlier. We can't just give it a name. That's because we created a constructor which requires us to add these parameters each time we create the object. So now when we create an object, we also have to supply a name and the subs. So inside here we'll type in CodePalace and 100 subscribers, for example. So as I explained earlier, once we have this constructor, it's going to automatically insert these values into the username and the subscribers so that we do not have to manually change each one after we create the object. Let's also go ahead and call codepalace.makeVideo and give the date of today. And now you'll notice that when we run the program, it's going to be identical to our last program, except this time we saved a lot of time with adding some values to the constructor, so it looked a bit more clean and so that it was faster to produce. Of course, at any moment in the program, you can go ahead and type in CodePalace username and you can change it to something else, such as 123. And as you can see here, now when we call the function after changing the username, we get 123 is making a video today. So providing a constructor just simplifies the process of inserting some values and some pre-made code. So if we go ahead and type in YouTuber coding in flow, we can go ahead and give the name of coding in flow, give it 1000 subscribers, and everything's going to work exactly the same way. Coding in flow dot make video tomorrow. Now we can go ahead and run it, and you're going to notice we will have coding in flow has 1000 subscribers and coding in flow is making a video tomorrow. Of course, that's because we decided to include this constructor which assigns the name to the username and the subs to the subscribers. Plus it also prints out this statement down here each time we create a new object. And in this example, we defined it inside the class, but we can also define it outside of the class. And to do this, all we have to do is go ahead and copy this place it here and do that. Then just make sure to copy this section right here, because now we've defined that this class has a constructor, but of course we did not define what it does yet. So to do that, we need to go under the class and type in YouTuber, which extends YouTuber with the string in the name. And then of course you just type in what we had earlier here. And like this, it's going to work exactly the same as earlier, except this time we've defined it outside of the class just by stating that it exists right here. So if we rerun the program, we're going to have the exact same output as earlier, with the exception that we define this outside of the class. So that was the basic introduction to how you can use a constructor in your class. In this video, we're going to be looking at some of the access specifiers. As I mentioned in the previous videos, we have public, we have private, and we also have protected. Now, the first thing to note is that we declared public because when you create a class, everything is automatically assigned to private. And private means that you can't access these variables outside of the class, which means if we tried to type in codepalace.username, we would not be able to use that because it is private. It only can be accessed from within the class. Public makes it so you can access it from anywhere. But let's go ahead and create an example, because of course, if we don't have an example, this will be very confusing. And what we're going to do is create a private access specifier, and it's going to contain a string of key. So this is information that we do not want the user to really be able to touch without us being able to tell them how they should touch it. It is sensitive information that should only be stuck to the class. The rest can be used by the user, that's why it's declared public. Now inside our constructor, we're going to go ahead and type in key is equal to the name at the index of 0, so it will take the first letter, plus we're going to convert to string the username.size, plus we also want to convert to string the subs size, so subscribers, and we're going to give it a random X 2021. So this just simulates a random unique username. So now, as you can see, we have the key declared as private, which means if we go to Code Palace and we type in Code Palace, it's not going to show us the key. And if we try to use the key and say it's this, and we go back here, there's going to be a red underline that says key is a private member of YouTube. You cannot use it. If you want to use it, you're going to have to make the field public, and it's going to remove it from the private and put it in the public section. But we want to maintain it private, and we're going to create what they call a getter, essentially. So this is going to be a function that allows us to retrieve the value from something that is inside the class. And to do this, we're going to create a function called print key, because this is the only way we want the user to be able to use this data. We don't want them to accidentally edit it for any reason. So we'll type in cout key is going to equal, and that's going to equal a key plus an end line. So now, while we cannot refer to this key directly because it's private, we can refer to it inside the class. So inside the public section or inside the private section, we can refer to key inside the class. And now if we want to go ahead and print the key, we just go ahead and type in codepalace.printkey, and when we rerun the program, you're going to notice that we're going to have the key printed out at the bottom. So the only way to get the value, of course, would be to create some functions that help us retrieve the value. But essentially, that's how we use the private access specifier, just to make sure that information stays inside the class. And later on, we're going to go ahead and see how the protected access specifier is used. But in this example, it doesn't make any sense because that will be used in an example that shows inheritance. But with that being said, that's actually all I wanted to show you in this video, is that we have the public access specifier to be able to refer to variables that can be edited and that we want the user to edit. And we use the private specifier to make sure that sensitive information remains inside the class. In this video, we're going to be going over encapsulation, which is a better way to control the data in your classes and make sure that only the variables that you want to be accessed are accessed in the way you want to access them. And those were a lot of words, so let's get immediately into using encapsulation for our program. Because earlier I showed you that we can create private classes which are created by default, so we don't need to specify that it's private to make it private, but we do need to specify that it's public to make sure it's public. So we're also going to add a different parameter, which is called password. So as you can see, we have two private variables. One is string key and one string password. And we can't access them directly because that would defeat the whole purpose of this encapsulation. And also the program won't really allow us to do it because it's private, of course. So we're going to have to go ahead and create getters and setters. So the first thing we want to do is create a function that sets the password. And we can't just go and type in codepalace.password to set the password, but we can go ahead and create a function that sets the password. So we can type set password, and we're going to insert a string, which is going to be the new password. Now inside here, we can refer to the password, and we can assign it the variable of new password. So as you could see, it was that simple to actually edit the variable. And this just makes sure that we edit it the way we want to edit it. Because if we just leave username and subscribers out in the open, there's no knowing what will happen to it later. Whoever is using it might use it incredibly wrong, which might lead to very bad problems in your program. So just for reusability, this is a very safe option when it comes to programming, is to provide getters and setters. So setters allow us to set the variable, and we also want to be able to retrieve this variable. So we're going to create a getter, and a getter must return a variable for it to function. So for example, we're going to go ahead and type in string get password, and these are just naming conventions for retrieving and setting the password or any variable you want. So for get password, we're just going to return the password. And the nice thing about getters and setters is that you have so much space to write any manual code you want. It doesn't just have to return a variable. You can also do a bunch of calculations inside there or add some print statements, whatever you want. But this just makes it so much clearer what we can do with the program and what we should do, rather than just changing variables randomly because we know how it works. So now we can actually go ahead and access this password. So first we're going to go ahead and type in codepalace.setPassword, and it's going to be abc123. My favorite password, and we're going to go ahead and type in cout codepalace.getPassword plus the end line. So with encapsulation, we made sure that all we can do with the password is set it and get the password. So it just makes sure we do what we're supposed to do and avoids future problems. So now if we go ahead and run the program, you're going to notice at the bottom, we're going to set the password to abc123, and we're going to print it out. And as I mentioned earlier, you can add whatever code you want inside here as well. So you can say password has been updated, exclamation mark, end line. And now every time we call this setter, it's going to execute that code as well. So when we run the program, it's going to tell us the password has been updated, and then abc123 will be printed to the console because we used the getter. And all of this was done while we had these variables maintained as private, which is a very robust way to build our program. And it's very recommended to use encapsulation just for the long run. It just makes sure your program does what it's supposed to do. But with that being said, I believe that covered all the basics you need to know about encapsulation. And in the next video, we're going to be going over inheritance. And finally, we will make it to that protected access specifier. In today's video, we're going to be talking about inheritance and how we can use that in C++. So the first thing we're going to do is create a class, and I have one already made. So it's a class of person, and in general, every person likes to eat and every person likes to sleep. So these are the two functions I've defined that are part of a person. Now what inheritance does is help us simplify the creation of new classes by inheriting from other classes. So for example, if we create a policeman, we don't need to recreate that he has to eat or he has to sleep. We're going to inherit that the policeman is a person, and that because he or she is a person, they get to eat and sleep automatically. But actually my previous example was of a YouTuber, so we're just going to create a YouTuber instead. And to inherit from a class, all you have to do is create public person, and this is going to retrieve all of the values and the methods from that class. Then inside here, we can add a public access specifier, and we're going to create a string of name. And this is only because I want to create a constructor, which is going to be the username, and the name is going to be set to the username. Below that, I'm going to create a function called void YouTube, create a block as always, cout name is doing a YouTube thing, end line. Now if we go to our main function and we go ahead and type in YouTuber, and of course we need to give it a username, and this time we'll just type in Philip. So there we created an object of YouTuber. Now what's special about this object is we can refer to eat, sleep and YouTube. Even if the YouTuber class only contains this function that says YouTube, we have successfully inherited the values from here. So now we can type in YouTube eat, YouTuber sleep, and YouTuber YouTube, so he can do that YouTube thing. So when we run the program, we're going to have all of these values printed, the nyom nyom nyom, the zzz, and also the Philip is doing a YouTube thing. So that was the first step of inheritance. Next I want to show you what multi-level inheritance is, because right now we only have one level here. It's taking from person directly, but as you might have guessed it, you can make this as deep as you want. So for example, we can go ahead and create a class called worker, which is going to inherit from public person. And then inside here, we're going to create a public key, which is going to be called string special key. And that's going to equal ABC123. Now, instead of inheriting from person for the YouTuber, we can inherit from worker. And since worker inherits from person, it's going to be a long line of inheriting, which means YouTuber is going to inherit from both person and worker. So now if we go ahead and type in YouTuber.specialKey, you're going to notice we can actually refer to that value and we can use it as we would normally use any other value. So we will print that value out, cout YouTuber.specialKey, and rerun the program. So you can see now we have ABC123 printed to the console because we have inherited from the main class, which is person, and then we inherited from the worker class. So it's a long list down, and you can do that for as many classes as you want. Now, the final thing I need to cover in inheritance is the protected access specifier, the one that I've been speaking about so much in the previous videos, but haven't had the chance to show you how it works yet. So right now we're going to go ahead and create a few classes. The first class is going to be called class A, and we're going to use the protected modifier this time. So string A is going to equal A class. And down here we're going to go ahead and type in void print A, and all we're going to do inside here is print the letter A. Now we're going to do the same thing with the B class, so it's exactly the same as the A class, except I changed everything with the letter B, just to make things simple. And below the B class, we're going to go ahead and type in class C, and this is going to extend from public A, public B. So actually I forgot to mention, you can also inherit from multiple classes at once. So this is an example of that as well. And the first thing we'll type in here is a private access specifier, which is going to say string C is equal to C class. And again, we do not need to specify this because it is automatically private, but just for the purpose of this video, to give you a better idea of how it works, I'm going to include it. And then we're going to add the public modifier down here, and I'm going to type in void print everything. So you can see what we can refer to and what we cannot refer to. Now, because we've included the protected access specifier, we can refer to these methods from the previous classes just by typing them normally, because protected allows us to access these in inherited classes. And I'm also going to print A plus B plus C. So as you can see, we can refer to string C here, we can refer to this string over here, and we can refer to this string over here with no problem because they are protected. And because this is private, we can refer to C inside the C class. But now it's time to go ahead and use this information. So we're going to type in C sample, which will create an object, of course, and we're going to type in sample.printeverything. And as you have noticed, that is the only method available for this class. So if we run the program, it's going to print A, B, A class, B class, and C class. But again, we cannot refer to this directly because first of all, this one is private, which means it's non-accessible outside of this class. And these ones are protected, which means you can only access these strings and these methods inside other classes that inherit from it. In this video, we're going to be going over what polymorphism is and how we can use it in C++. So the first thing I want you to note is that we created a class that's called person, and it has one public function that says say hello. And all it does is print to the console, person says hello. Now let's go ahead and create a second class, one that's called policeman. And this one is going to inherit from person. So all we're going to do is go ahead and copy this function over here and paste it inside policeman. What you're going to notice immediately is that we have the exact same function as we have in person. And the point of polymorphism is that you can use this function with different classes to create different effects without having to give it a different name. So what we're going to do inside here is change this to policeman. And we're going to copy this one more time and place it under. And we're going to call this one YouTuber. And here we can just type YouTuber says hello. So now we're going to go into our main console and we're going to type in person is going to be a person object, policeman is going to be a policeman, and YouTuber is going to be a YouTuber. And just like that, we can go ahead and type in person, say hello, policeman dot say hello, and YouTuber dot say hello. So we are using the exact same method for all three of these classes, and what polymorphism helps with is making it more specific to the class, letting us use the exact same function name, but of course printing a different result. In this video, we're going to be going over exception handling in C++. And to get started, I'm going to paste these three constants, which are going to be used for an internet connection. So connected means we have a code of 111, not connected is 222, and unknown is 333. These are just random codes I came up with for our sample internet connection. Then we are going to create a function called connect to internet, which will take an integer as a parameter, and that's going to be the internet code. So to start it off, we're going to create a try and a catch block. So inside the try, we're going to write if the number is equal to 111, then we can just paste that we are connected to the internet. Else if the number is equal to 222, we're going to throw an exception. And we're just going to throw 222 as the exception. And we're going to do the same thing for a number that's equal to 333. So these are just going to be considered error codes for what happens if we do not have the desired output that we're looking for, which is an internet connection. So with that being written, we can now go ahead and add our catch block. And inside here, we're going to type int error. So whatever we throw here is going to be transferred to the catch block. So now we can use this error to handle these errors. So we're going to create a block in here. And the first thing I want to paste inside is the error that we receive. So if we have a connection of 222, it's going to print to us that our error is 222. And very similar to what we did in the try block, we're going to do in the catch block. So if the error is equal to 222, then we're going to tell the user to please check your connection. Else if the error is equal to 333, we're going to tell them that we have no idea what's going wrong, so they should contact their service provider. Now inside int main, we're going to go ahead and connect to the internet. First, we're going to provide the connected constant, which will just tell the program that we are connected. So let's run and see what happens. So since we got the desired output, it's going to skip everything else because there was no errors, there were no exceptions, and it's going to do the desired function, which is tell us we are connected, and preferably send us to a web page or do something that requires an internet connection. But in the case we cannot do that because we are not connected, it's going to give us an error of 222, which is going to tell us to check our internet connection. And in general, you would add the functionality inside this error block so that we can fix it and we can continue with trying this connect to internet function again. But what happens if the problem is unknown? Then you're going to notice we'll get this error 333 and it's going to tell us to contact our service provider for some help. So as you could see, with try and catch, we were able to handle some unknown situations, such as pretend you create a function that's supposed to divide a number by something else. What happens if the user inserts a letter or the number 0 instead? you're going to have two problems. One is going to be trying to divide a letter by any number, and the second problem is going to be trying to divide a number by 0. Those are both problems that shouldn't happen, but that the user ultimately will probably do. It doesn't matter if they are a genius or an idiot. When it comes to technology and programs, everything will happen regardless of how smart they are. So you need to be prepared for most situations, and with try and catch, you can do that. You can create some exception handling that will prevent the users from destroying your program. Now I'm going to create another function right below that, and this function will be called do something. All it does right now is check whether the number is more than 100. If it's more than 100, the program is happy. If it's not, we're going to get this number is too small exception. This time I went ahead and created a constant char pointer that has the alias of message. So every time we throw an exception with a string instead of a number, it's going to print that message instead. So for example, let's go ahead and do something such as print the number or insert the number of 1. And now when we print the program, we're going to get the number is too small exception, because that is the data type we defined to receive when they throw the error. Now the final thing I should show you in error handling is that, let's pretend you don't know what error is going to be thrown. That's fine, you can just add 3 dots and that means it will handle whatever is thrown. Regardless of what you throw here, these 3 dots are going to receive it and tell the program that you should execute whatever is inside here. So we can type in an error has occurred. And now when we run the program, it's going to say an error has occurred if we have a string or if we even have a random number such as 111. It's always going to be an error has occurred. And of course, if we enter 1000, our program is going to run smoothly because that is exactly the input we were searching for from the user. So everything will work perfectly. But with that being said, guys, this was actually the final video of this beginner series for C++. I'm going to try to make a few sample programs so we can actually see C++ in action. And from this point on, you're going to have to refer to documentation online. Every time you have a problem, like let's pretend you have to convert a string to an int, go on Google and type in how to do string to int in C++. And you'll find out that you can do something such as stoy and insert the number that you want to convert. Then we can go ahead and just see out this funky number, which was originally a string, and you're going to get 20. Even though we inserted the string of 20, we still got out the integer value of 20, which we have defined as an int. So that's going to be you from now on. You're going to research what you need and you're going to use it efficiently. And with that being said, I want to thank you guys for following along with this series. It really motivates me to make more tutorials. And of course, if you have any comments or questions or even some recommendations, feel free to leave it in the comment section down below and I'll do my best to look at it. Otherwise, with that being said, I wish you guys a wonderful day and I will see you in the next video.